evaluate this iterated integral. So if we look at closely, here is a problem. The inner integral is complicated because when we want to integrate, let me forget about the limits for now, e raised to y over y with respect to y, then we have a fraction of two functions and there is no fraction or quotient rule. We can convert this into a product, writing e raised to y times 1 over y, and use integration by parts. I mean, that's possible, still difficult. Instead, if we can switch this order, this order of integration, instead of y, if we do with respect to x first, then this function behaves like a constant, just like say 10, 5. Then we can easily find the integral. Okay, so let's try to do that. And this integral is, let's try to graph the function. So here, this inner is y, so this is y equals root x to 1/2, and outer is x, so this is x equals 0 to 1/4. Let's try to graph this curve. So y equals root x, so this curve is y equals root x and 1/2, y equals 1/2, so y equals 1/2, this is y equals 1/2. Okay, so this point is 1/2. This is origin, this is the x-axis, this is y-axis. So this line is y equals 1/2. And x equals 0, that's the y-axis, by the way. So x equals 0 is the y-axis. And x equals 1/4, vertical line, this is 1/4. So x equals 1/4. So basically this integral is over this region. Okay, and the inside was in terms of y from root x to 1/2. So inside is root x to 1/2, so root x to 1/2. So this was a type 1 region. Okay, this was given as a type 1. So now if we can convert this in terms of type 2, that means we want to go from this horizontal direction. So let me erase this. Okay, we want to convert in this direction. It's given in this way. Or we can write the region here. This D is in fact x, y. If we look at x is in between 0 and 1/4. And y is in between root x and 1/2. The way it's given is type 1. Same region, this can be written as x, y. Now I want to go in horizontal, so this direction. Okay, in this case x is in between where? This is x equals 0 to this curve, y equals root x. If we square both sides, we get x equals y squared. So up to y squared, this direction, and this arrow from y from 0 to 1/2. So y is from 0 to 1/2. Okay, so this iterated integral is same as doing the integral over d, and this d is this d. Then we can change the order of integration. So this is same as, this integral is same as, let's say that double integral I is same as. Now I want to do in terms of x first, then y. So in terms of x, so I need to write down the limits for x. X is 0 through y squared. So x equals, and outside y is 0 to 1/2. And our function remains the same, ey over y. Okay, now this is an iterated integral, so let's do this part, which is easy because this function with respect to x behaves like a constant. So y from 0 to 1/2, and integral of this is just that constant survives, and with respect to x times x. It's like 5, antiderivative of 5 is just 5x. And we want to go from 0 to y square, 0 to y square, this is x equals, okay, x equals 0 to x equals y square, and outside we have dy. This is 0 to 1/2, in fact y values. Now replace x by upper limit y square minus replace x by lower limit 0. So upper limit is ey, let me do it, ey times y square over y, one copy of y cancel, so this y, ey times y, minus lower limit when x equals 0, everything is 0, so don't have to write lower limit dy. So we get a product, but this one is easier than the initial one if had we tried that way. So let's do the integration by parts, and we know that when we have u times dv, that's just uv minus integral v du. So we need to choose u so that its derivative is much easier. So y, derivative of y is 1, so in this case let u be, so for this particular integral let u be just y and dv be e raised to y dy, then du is just 1 dy and v is just ey. Okay, now this integral becomes, using this rule, uv, so y times ey from 0 to 1/2 minus 0 to 1/2 integral v du, so ey 1 dy. Evaluate at the upper limit and lower limit. In fact, y equals 0 makes the lower limit 0, so don't have to evaluate. Upper limit 1/2 e raised to 1/2, which is same as root e, lower limit 0, minus integrate ey, just ey, again is from 0 to 1/2. Here 1/2 root e minus upper limit, replace y by 1/2, e raised to 1/2 is root e minus lower limit, but this negative and this negative from upper limit minus lower limit, we need to distribute, so this becomes plus lower limit 0, e raised to 0, which is 1. This would be the answer, but these are like terms. One copy of root e, negative, positive 1/2, positive 1/2 minus 1, so negative 1/2, so there is 1 and negative 1/2 copy of root e. Okay, final